Hello, myself Vaishnavi. I'm currently pursuing my BE in Sri Venkateshwara College of Engineering. I'm doing on the topic 3D printing of ear, bone, and skin. Topics to be covered are introduction, 3D printing of ear, 3D printing of bone, 3D printing of skin, and their applications. Before knowing, let us know what is bioengineering. Bioengineering is also known as biomedical engineering. It is a multidisciplinary field that applies principles of engineering, biology, and medicine to develop innovative solutions and technologies. It involves the application of engineering principles to design, analyze, and create biological and medical systems. The primary goal of this bioengineering is to improve human health and well-being by advancing medical technologies, diagnostics, prosthetics, tissue engineering, and other medical interventions. Bioengineering work on a wide range of projects, like such as designing medical imaging systems, developing artificial organs, enhancing drug delivery methods. 3D ear bioprinting. 3D printing of ear is also known as biofabrication or bioprinting, is an emerging field in the regenerative medicine that aims to create functional human ears using additive manufacturing techniques. The process involves depositing layers of biocompatible materials such as cells, bioinks, to build a three-dimensional structures that mimic the shape and properties of natural ear. The 3D bioprinting is an advanced manufacturing technique that allows the precise deposition of biomaterials and living cells in layer by layer manner to create functional 3D structures. The process of 3D ear bioprinting typically involves image acquisition, the first step to acquire 3D image or scan the patient's ear. Digital design. Once the 3D design is obtained, it is processed to make the model of the ear, and this digital design serves as a blueprint for such as the CT scan and 3D scanning technologies. Biomaterials and bioinks. Bioprints use specialized bioinks which are biocompatible materials that contains living cells. These bioinks are crucial for creating tissues with appropriate cellular composition and structure. In this case of ear bioprinting, the bioink would need to design the mimic properties of human ear cartilage. Printing process. The bioprinter is loaded with the chosen bioink following the digital designs for creating the layer-to-layer 3D structure of the ear. During this printing process, the living cells that is within the bioink need to be carefully maintained. Maturation and integration. After bioprinting, the 3D ear construct requires time to mature and integrate with the surrounding tissues. Transplantation. Once the 3D print ear has been matured and developed a blood supply, it is transplanted into the patient. Ideally, the patient's own cells are used to minimize the risk of rejection. It is important to know that while 3D ear bioprinting shows promising potential, it is still a relatively new technology with various challenges to overcome, such as ensuring cell survival and function during printing process. Applications in ear reconstruction. 3D printing enables precise and customized ear reconstructions for patients with congenital or acquired ear deformities. Advantages of 3D printed ears: better aesthetics outcomes, improved patient satisfaction, reduced surgery time, and enhanced biocompatibility. 3D bone bioprinting. The 3D printing of bone is also known as 3D bioprinting, which aims to create the artificial bones for various applications that is included in the medical purpose. The concept behind this 3D printing of bones involves using specialized 3D printers and bioinks to create the structures, which are carefully layered to construct the 3D dimensional bone-like structures. The process that generally involves the steps are medical imaging. The patient's bone structure is first scan using the medical imaging, that is CT scan or MRI scan. This scan provides a digital representation of the bones and its dimensions. The digital design. The scan data is then converted into digital form and it is computer-aided design structure. This digital model serves the 3D printer to create the physical structure. Material preparation. The suitable bioink is prepared by combining living cells, biomaterials such as hydrogels or biodegradable polymers, and growth factors. These components provide the necessary biological and mechanical properties for the printed bone. Printing process. The 3D printer deposits the bioink layer by layer following the digital design. Specialized printing techniques such as extrusion based on inkjet based methods that are used to precisely position the bioink for creating the desired structure. Post printing processing. Once the printing is complete, the printed structure undergoes the maturation process. This may involve incubation in a bioreactor to provide optimal conditions for cell growth and tissue development. During this stage, the cells within the bioink differentiate and form a more mature and functional bone tissues. The ultimate goal is to create a 3D printing of bone is to create a custom-made bone implant that can be used in various applications, including surgeries, orthopedics, and regenerative medicines. However, it is important to note that 3D printing of the bone is still a developing field. There are several challenges that need to be addressed before taking this medical treatment. Benefits of 3D printed bone implants. Perfect fit to patient's anatomy, faster healing and recovery, reduced risk of implant rejection, improved long-term outcomes. 3D skin bioprinting. 3D skin bioprinting is also a bioprinting was a promising area of research and development in the field of regenerative medicine. The idea behind this 3D bioprinting is to create living tissues or organs. The process includes cell isolation. The cells are obtained from the patient's own tissue or from a donor. For skin bioprinting, usually various types of cells like keratinocytes and fibroblasts are used. Biomaterials. A bioink is created to hold the cells in the place during the printing process. And this bioink plays a crucial role in providing the structural support and nutrition for the growth and for the differentiation. 3D printing. The 3D printer deposits layer of the bioink and cells, following the pre-designed blueprint based on medical imaging data or other models. The printer precise is crucial to ensure the correct positioning of the cells and overall structure, maturation and growth. After bioprinting, the structure is placed in bioreactor which provides an environment for the cell growth and maturation. Implantation. Once the tissue has matured and is deemed ready for transplantation, it can be implanted into the patient, promoting wound healing and tissue repair. It is essential to know that the technology may have advanced since the last update and there might be more recent developments in the field. So these factors help such as biocompatibility, cell viability, and the ability to mimic the natural structure and function of nature's skin. But the research in this area are shown promising results in the laboratory. Widespread clinical appliances of the 3D printed skin may still be used in the future. Advantages of 3D printed skin grafts. Reduced risk and rejection, faster healing and regeneration, personalized treatment for each patient, enhanced aesthetic outcomes. Thank you.